All right, I'm going to do a live lecture today, obviously, so this is just the problems worked. We're using something called the logarithm law of equality and logarithmic properties. The logarithmic properties that you've been using, the ones that combine, the ones that you can, it's condensing and expanding. I'm going to show you that now. So I don't want to talk about it. I just want to get into the work. So here we go. So when we're solving logs and we have logs on both sides, we're trying to basically get it where we have the same base. That's like the goal of this, basically, when we have the same base. And what's the base? This number here. When our base matches, we can do a lot of cool things. But I'm going to show you how to put these together. So using our rules, using our product rule, check out what I can do here. I can basically look at this. This is log base 2, log base 2. I can put this together. When I have the addition, that means multiplication. So watch how this goes together. Log base 2. And I'm going to put it in the pretty order. I'm going to put the number 3 first. And then I'm going to put the x next. So we only had 2 days of practice on condensing and expanding. So you might need to dig deep. There's going to be a lot of class time to work today and tomorrow. So check out this one. I'm going to go ahead and show you how I did this. So this is the left side. I put it together. Again, if you weren't here for these rule sets, I don't know what to tell you, but it's the expanding and condensing. Now check out this one. This one's a little bizarre because I have a 2 in front. This rule right here is called the power rule. And basically what it allows me to do is I can take this 2 and I can move it. I can take this 2 and I can move it here. And I can move it right there. So it's log base 2, 3 squared, which ends up being 9. So watch how I'm going to write this. I'm going to write this as both of these are log base 2, log base 2, log base 2. I'm going to put in my parentheses 3 squared, and then I'm going to put in my other one 5. And why is that? Because this means multiplication. This is where you now have to actually do some multiplication. So check this out. I'm going to keep this here, log base 2 of 3x, because that's combined as much as it gets, equals log base 2. I'm going to multiply these numbers together. 3 squared is 9. 5 is times 5 is 45. So this is 9 times 5 is what we'll get, which will give us 45. So I'm going to end up with log base 2 of 45. And now check it out. We have a log on one side with the same base as 2, and another base on this side, another log with the base 2 on this side. So now what ends up happening, it's basically I can ignore this log base 2, and I can just set these two numbers to equal each other. So here we go, and I can divide by my 3, and I end up with x equals 15. So that's how that goes. I'm going to go straight into the next one. All right, number 2, here we go. I'm going to switch my, what's it called? Ink to purple. So I have log base 2, 27. All right, that's awesome. This is already basically good enough here. Check it out. And then I have this 1/3 log 2 to the x. I need to move that 1/3 log up. So I'm going to show you how to do that. I have log base 2, 27 equals log base 2 x to the 1/3. So check it out. Even though we have an exponent there, that's okay on these problems. I have a log base 2, a log base 2, and I have a term here and a term here. Now watch what I can do next. I can remove the log because they match, and I can just solve this x to the 1/3. Now don't forget that one little rule we have to clear this. What I want to end up doing, I think, hold on one second. Sorry, I got interrupted. What you're going to do is you do that opposite, where you have to raise it up by 3/1. I'm out of room over here, but I'm going to multiply by 3/1, and that will cross these two out. But if I do it on one side, I have to do it on the other. Y'all, I have no idea what 27 to the power of 3 is, so I'm just going to leave it. You can leave it like that. I'm sure we could do it on Desmos, but that's it. It looks like a funny problem. This one just looks funny to me. I feel like it would have been better if it was like 3 log, but whatever. Hopefully that's right. I think it is. It just looks weird. All right, I'm going to the next one. Now, check this out. Do y'all see what's going on here? We have to combine everything together. I'm going to show you what that looks like on this first thing. I'm going to blue ink. Here we go. Log base 7, log base 7, log base 7. Using the rules of condensing. I have product, quotient, and here we go. Log base 7. And I'm going to put them all next to each other at first, and then I'll clean it up on the next line. And then minus 3, minus means division, so it's going to be on the bottom. So I have that equals, and then log base 7, 3 times 4 is what I end up having there. So I'm going to rewrite these cleanly. So again, that minus sign indicates it's going to be beneath on the denominator. And then this is 2x's. X times x is x squared, y'all. X times x is x squared. So I end up with x squared over 3 equals log base 7, 12. So now I have log base 7, I have a term up here. So now I can set these equal to each other. X squared divided by 3 equals 12. I'm basically running out of room. That's always fun. How do I get rid of this 3? This says x squared divided by 3. We do the opposites. So we're going to multiply by 3 on both sides. And then I'm going to have to use more space. So I'm going to say this is spot A. I'm going to take us to spot B. When I multiply this out, this will cancel out, and I'll end up with x squared equals 12 times 3 is 36. And then whenever we take the square root, you're going to end up with, here we go, you're going to take the square root. Let me do it in purple. I'll do it in black. Do the square root. Why am I doing the square root? Because that's how you get rid of this x squared. And you end up with x equals plus minus 6. When you're going from square root to square, that's when you take the plus minus 6. And that's what you get for number 3. Pretty cool. Moving on to number 4. All right, more of the same stuff. Let's just get into it. Log of 848 minus log 8 of x. So this is going to be 48, let's see, over x, and then my log base 8 equals log base 8, 4. All right. Log base 8 is here, 48 over x is here, so I can just basically remove these out. This is called the law of equality. It isn't that crazy. Okay, this is bizarre, and a lot of y'all will freak out about how to solve this, and so I understand, but I'm going to help you with this. This says 48 divided by x. 48 divided by x. It's weird. We haven't really done this in this class, but watch what I'm going to do. I'm going to multiply by x on both sides. When I do that, this x cancels out, and then I can write it out as 48 equals 4x. Then I can divide by 4 on both sides, and I get x equals 12 after that for number 4. All right, moving on to number 5. This is cool. The parentheses indicate that it is one term up here. You don't have to expand. You don't have to whatever else. Pay attention to your parentheses. One of the most important things in math are parentheses. So this is just one term, and this is just one term. And they both have log base 7, so check out what I can do. I can just go straight into this. Already set it equal to each other. I'm going to subtract my 3x. Whenever we group, we got to make sure to subtract. So I end up with 5 equals 5x minus 12. I'm going to add the 12 on both sides. And I'm going to have 17 equals 5x. I'm going to divide out my 5 on both sides. And now I have x equals 17 over 5. 17 over 5. That's what I get for that one. Pretty straightforward. Hopefully y'all can see that at this point. Now, this one is not as straightforward. Here we go. I'm going to go ahead and put this together and attempt to do it in one thing. Here we go. Log base 2 of 2x. I need more room for that. I see a minus sign, which means draw that. I have a 2x minus 1 on top. I have an x plus 5 on bottom. Equals, check out this weirdness right here. I'm going to write it in one step. You'll see that we're not quite done yet. That 1/2 is going to be put up in this position. Minus, this 2 is going to be put over there. Lots of 2's. 2, 2, 2. This 2 is right here. This 2 is right here. This power 2 went over here, just so you can see which one's which. That looks like a lot, y'all. So this side is fine, but this side needs to basically be condensed. If you typed in 36 to the 1/2, that means the square root of 36, which will give you 6. Log base 2, 6, minus log base 2 to let's see, 2 squared is 4. And we're not quite done. Now we have a minus sign. That doesn't mean subtract the numbers, y'all. It means divide the numbers. So we have 6 over 4 is equal to log base 2, 2x minus 1 over x plus 5. And then when it's all said and done, you end up with the logs canceling out. The logs cancel out, and you can basically solve this. I'm not going to make y'all solve this problem because I don't think we have anything this hard to do. But that's really it. Let's see. Do I need to do anything else? No. And for those who are interested in how to solve it, I'm going to basically clear some space, and I'm going to do it over here. I'm going to switch it to purple ink. For anyone who's interested in the algebra in this, I'm going to solve it right here. 2x over 1. X plus 5 equals, y'all, you see the 6 over 4? I can reduce the 6 over 4 to 3 over 2. They both divide by 2. Again, this is not on the test, but this is real algebra. I'd like y'all to see it. I can solve this by doing cross multiplication. When you have one fraction on one side and another fraction on another, you can do cross multiplication. And you put it together. So I have 3x plus 5 equals 2 times 2x minus 1. That's how you remove that fraction. You'd end up with 3x plus 15 equals 4x minus 2. Then you can solve it from there. I don't want to keep going. But that's what that looks like. That's all 6 problems worked. If you have any problems with this, I can help you in class. But try to remember that this is like, you've been shown the rules. So when you're like, I don't get it, I understand that you don't get it. That means you should try. So look at your rules, look at the work we've done. Don't act like you can't do this. It just requires multiple steps. That's the difference. So y'all have proven your worth. Y'all have shown that you can do math. So like, I'm not going to fall for the, oh no, I can't. No, that's tired and that's over. So good luck and see you in class today.